Welcome to my 390 FE Ford Big Block engine build video. I just wanted to front load some information before we get started so that you're fully aware of what this video is all about. It is going to be a start to finish assembly of a Ford 390 FE Big Block that started off as a 360 FE Big Block. The level of detail will be moderate to high, and the video length is 2.5 hours. Now that is a lengthy video, so I included some shortcuts in the description that will allow you to skip forward to find the information you're looking for. Now I try to cover most of the build topics in this video in great detail, where I'm talking about them at length, giving a lot of information and providing a lot of video footage so that you can better understand how this engine's going together and how it functions. But also, be aware that some of these steps, I just covered them in moderate detail. So I will definitely talk about them, but I'm not going to be showing, the video in real time as I put the engine together, because it simply would just take too long. Most importantly, please note that there are certain topics that are just not covered in this video, and it doesn't mean that these things aren't important, but take a look at this list and just be aware that there are some things you might want to do some extra homework on. If you feel like I skipped a step or you don't understand something in the video, you're welcome to leave a question or a comment down below, and I'll do my best to get back to you and answer that question. So I'm happy to do that. All right, that's about it. I think we're ready to get started. So I hope you enjoy this video. Hope you learned a lot, and let's build a Ford FE390. This is our Ford FE360 block that we're going to be using in this video. And when we're all said and done, this 360 will become a 390. And that's the cool part about these FE engines, is a lot of the parts are interchangeable. So we'll get into that. As far as big blocks go, a 360 or even a 352, those are relatively small displacements for such a large block. And as you can see, this block is pretty darn big. I have a small block 289 Ford on the engine stand behind this block. And if you're, I'm not sure if you can see it, but it is a lot smaller than this big FE block. So it definitely earns its name big block, but only by its physical size. I mean, 360 cubic inches is really not a whole lot for the size of the engine. In fact, even Chevy had a 400 small block, that was the same size as a 350 small block, but yet that had 40 additional cubic inches in a much smaller package than this FE block. So, there's a lot of crankshaft improvement that can be used in this exact block, in this 360 block, and that's what we're doing. We're going to be putting a much bigger crankshaft, a different rod and different piston into this block, and we're going to get that 390 cubic inch. Actually, it's going to be 396 cubic inches, because this block has been bored 30 over, and that gives us like six additional cubic inches. So when it's all said and done, 396 cubic inches in this big block FE Ford, and it's going to run considerably better. So one thing I want to point out is that you'll notice there is a 352 cast right into the front of the block here. And you'll actually find that 352 cast into the front of just about all of the FE blocks. So don't be confused. If you see even like a 428, FE Ford, it might say 352 in the front of it, and you think, oh, this is a 352, but you might actually have a 428 on your hands. So you have to be careful, and you kind of have to be knowledgeable about what what these blocks actually look like when you're out there, trying to find yourself a good block to build. One of the reasons that you want to move away from building a 360, at least unless you can build a 360, there's nothing wrong with it, but you're giving up a lot of compression. And that's what I wasn't comfortable with, in building a 360. I thought, geez, you're giving up so much compression, because these engines, 360s, did not have a lot of compression to begin with. And in doing some research, it sounds like the compression was actually lower than what they were advertised. And so what that had to do with, it had to do mostly with the piston themselves. The compression height on the piston was really short, and the piston sat below deck on the block, and they just didn't squeeze out a lot of compression. Different on the 390, of course, you have a different stroke, so that's going to help for sure, but you also have a piston that has a taller compression height. 1.76 compression height on the 390 piston, so that piston sits much closer to the deck of the block, and you're going to get better compression out of it. So like this build here, we're going to get about 9.5 to 1, 9.6 to 1, something like that, static compression, and it's going to just be, you know, a major power increase just from the compression alone. And then of course on top of that, you got all the additional cubic inches as well. So I mean, it's a win-win situation here, okay? And that's what's cool about these FEs, is so much of the parts are interchangeable. So I'm going to go ahead and put this chart up here, and you will be able to see the different bore and stroke combinations that Ford used on these FE engines. And as you can see, the 352 and the 360 use the same crankshaft, but the bore was just slightly different, which is that 8 cubic inch increase from the 352 to the 360. But then look at the 390. 390 has the same bore as a 360, but it has that bigger 3.78 inch stroke. And you'll also notice that the Ford 406 and the Ford 427 also had the same crankshaft with a 3.78 inch stroke, but the bore was different. So, you know, you'll get the idea by looking at this chart, but Ford, you know, they had a couple different blocks, or probably like, you know, 3 different blocks with a bore, you know, different bores, and then they had several different crankshafts that they used between them to get their, you know, different cubic inch motors and combinations that they had, and their various years and models that they produced. So we're going to go ahead and take a look at some different parts that we're going to be using in this engine. Go over to the rotating assembly on the bench, take a look at that, and I'll kind of give you guys a rundown of what we're going to be putting inside this block. So anyway, I hope you were excited about learning how to convert a 360 into a 390. So let's get started. All right, over to the bench here. We have the original FE360 cylinder heads here. And it's important to point out that these are the same exact cylinder head that would be on a 390. Now on the FE, there were some differences in head design depending on how high performance the application was. And so of course, if you get into those 427s and 8s, and you're gonna get to some different cylinder heads that were definitely better flowing and better performance than these very standard truck heads. But these are the same heads that would be on the 390 of the same year. And most importantly, these heads will support around 375 horsepower. Some say 400 with the right camshaft if you were going that route to make a more performance-oriented engine. Now, in this particular 390 build, we're not looking for those big horsepower numbers. What we're looking for is a good street-driven truck motor that makes good horsepower and torque, but very usable at low RPM power, which is why we're going with that smaller MTF4 cam. So these cylinder heads are the factory 360 heads. They're going on the 390. Again, not giving anything up there. We are, using heads that have been completely refurbished, new valves, proper valve springs for the cam that we're running. Of course, a new valve job and things like that with the new valves. So these are that C8AE casting. So these were originally casted in 1968, or at least they're designed for the 1968 year, and then they continued to use them throughout the 1970s as well. So these heads will support the kind of power that we're trying to make, no problem, which is about 300 horsepower, and hopefully well over 400 foot-pounds of torque. Now the crankshaft. This is where we are changing parts, right? So here we go. So we have the 390 crank. Now this crankshaft here is larger or has more stroke than the 360 crankshaft, the original crankshaft. And we're talking about, we're going from a 3.5 inch stroke to a 3.78 inch stroke. Okay. So that's a pretty big difference. And that's where you pick up those 30 cubic inches that we go when we're going from 360 to 390, and so that's gonna be more horsepower, more torque, and that's great. Now, also, kind of an interesting thing: the 390 rod that we have here, this 390 rod, this one happens to be like a mid to late 70s rod, but this particular rod is actually shorter in length than the factory 360 rod, because this crank has so much more stroke that they had to shorten the rod length so that the piston didn't pop out the top of the block. Okay, if that makes sense. So you're actually running a shorter rod, and in general, you want to use typically the longest rod possible when you're building an engine, because the longer the rod, the more efficient the engine is, because the piston stays at top dead center longer. If you want to get into like the math on that, but this is the way it's designed. This is the application. So it's a 390 rod, and then this piston is it's made by Keith Black, I guess, which Keith Black is a name brand, of course, but they have all kinds of different piston lines that they make, and this one happens to be the Silvolite. So it's a 30 over, true flat top with a large valve relief. It is a hyper-eutectic piston. It is a cast design, just like the factory, but this one is a hyper-eutectic, meaning that it has more silica content, and it is lighter in weight, and it also has some other types of properties to it that is good for performance. So one thing I will mention, that in this particular application, we are going to have an offset pin, which means that the pin here is offset just slightly, so that you have a side load, slight side load going up and down in a cylinder, which makes for quieter operation. In a real, like a forged piston that's meant for performance, you're going to have a center pin, which means there's no side load. It's straight up and down. I'm sure there's a side load, but it's much more centered, and there's less of a side load than in an application like this. So there's just a few things, that engine knowledge, but this is meant for, a street application, not a race application. It's perfect for what we're using. Okay, and then of course we have our Felpro gaskets, and to be quite honest, I haven't checked the thickness on these, and I will check that soon, but the part number there, 8554PT. And what's nice is they are marked front. So for all you people that have had an experience where you put these on the wrong way and overheated your engine, Felpro's gotten wise to that, and they're trying to help you out. So read. Okay, so anyway, heads, crankshaft, piston and rod, and head gasket. So these are some of the components we're using to make this 360 a 390, and I'm pretty excited about it. So it's going to be a good running engine. All right, so the camshaft that was selected for this engine build is the Melling MT4 camshaft. It is a hydraulic flat tappet camshaft, and this is a super old grind. This is kind of a tried and true RV truck cam. Now, some of you who are watching this video, you might be like, hey man, that's a dinky little cam, that's not gonna make any horsepower. Well, that's in large part correct, because this is going to be a very mild 390. It is going back in that 72 Ford F250 pickup truck, and so we're not looking for a real big cam. So again, the reason that we're going to the 390 is because we want to have a lot better throttle response, towing capability, a lot more torque, and so we're still picking up a lot of benefits by going from a 360 to a 390, but we don't want to use this big old camshaft that's going to cause drivability issues and things like that. Using factory heads, factory drivetrain, factory valve train, all of that, so we just don't want to go too big on the camshaft. Okay, so we have in this photograph, you can see that the camshaft has been installed into the block. And when you're installing a camshaft, just a few things you want to keep in mind. One is the use of assembly lubricant. You want to lubricate the entire camshaft, not just the cam bearing journals of the camshaft, but also all of the lobes. And you want to use an assembly lubricant that has some stick or some staying power. It's not going to just fall off. So use something kind of something that kind of thick that will stay on there, and use a lot of it. And then I recommend installing camshafts with the crankshaft out. So it's almost, my first step really after I clean a block and get it ready for assembly. I almost always install the cam first. and then worry about the rotating assembly later. Get the cam in there. You can see in this next picture where I'm installing this camshaft. That's actually a small block Ford. I'm just using the photograph so you can see kind of my hand placement when I install a camshaft. With the crankshaft out of the way, you can reach inside the block and guide the back of the cam through the block past the cam bearings. And you don't want to nick or damage one of the cam bearings, and so you just want to be really gentle and guide it all the way back, and so that it's sitting where it belongs on the cam bearings. So it's pretty self-explanatory. Installing a camshaft is not hard. Make sure it's well lubricated, and make sure you do it with the crankshaft out so that you don't damage your bearings. Okay, now that the camshaft has been installed, we can move on to preparing the block for the crankshaft. And crankshafts just literally sit right on top of the main bearings. There's really nothing to it, but you have to install those main bearings first. So what you're looking at here is the main bearing set for this 390, and this happens to be a full groove main bearing. And that means that there is a groove in the bearing on both sides. So bearings are, 2 pieces per journal. And sometimes you'll have like a half groove, meaning that one half of the bearing has a groove in it and the other half does not. It's flat. But this set in particular is a full groove. The groove goes all the way around the journal. And what that does is it provides more oil at the journal. So that's good. This engine is fairly tight on the bearing clearances within spec, but a little bit tight. So you have a little more oil there at the ready, which is good. But it also reduces your available oil pressure by a little bit. So there's give and take there, but I'm confident that will be just fine. You'll also know there's a hole. You'll see that there's a hole there in all the bearings, and in a half groove bearing set, you'll probably only have a hole on one half. And of course that half, whatever half has the hole is going to go on the block side, because that's where the oil is going to be coming through the block. That's important to know. Now in this particular set, the top half and the bottom half of the main bearings are identical. So there's no difference. And that's just how this particular bearing set is set up. So there is no top, there's no bottom. You can't really mess that up, and I guess that's kind of cool. It's dummy proof, but for the most part, if there's a hole in the bearing, make sure that it lines up with the hole in your block so that you have oil that's flowing through the hole and lubricating your journal on your crankshaft. Okay, so that's a little bit about the main bearings that we're going to be running. In this next photo, you can see that I have the bearings installed in the block, and I have some lubricant also sitting on those bearings so that the crankshaft is ready to set down. You definitely want to lubricate the bearings before you install the crankshaft. Now you'll notice, or hopefully you can see, that the third bearing in, or the middlemost bearing, that bearing has a skirt on each side, and that bearing is the thrust bearing, okay? And it actually kind of controls the crankshaft from going front and back. And so we need to pay attention to that, okay? So we have to pay attention to how much clearance we have in movement going front and back. There's a very minute amount of clearance that you should have, but not enough and too much are both a problem, especially not enough. And so that you will notice that, the centermost bearing on any Ford, small block or big block, the centermost bearing, the thrust bearing, looks a little bit different than the other 4. Okay, the other 4 are identical. So so we're kind of ready to set the crankshaft in. But before you set the crankshaft in, we got to talk a little bit about a rear main seal. Now on these older Fords, you're going to use a 2-piece rear main seal. Ford eventually went to a 1-piece rear main seal, which is great. They work really well, but the 1-piece rear main seal, you're not going to see that come around until like 1986 or 87. So up until that point, we used a 2-piece rear main seal. So in this picture you're looking at here, you can see that I have the rear main seal, or half of the rear main seal, sitting in the block, and you'll notice that I have it offset. It almost looks like I didn't install it all the way. So this is the very back of the engine. That's where the rear main seal would go, of course. And you can see that I have on the left side there, I have the rear main seal protruding out of the block there, and that is purposeful. So you can install these flush on both sides with the block, but by providing a little bit of an offset, we're actually preventing oil leaks, okay? And as you can kind of imagine, that would, by having the offset there, you're preventing oil from being able to squeeze past the two, squeeze past the gap that might be there if the two halves of the bearing, the two halves of the seal didn't fully meet with each other. You could have some oil squeeze past there, and we don't want that. So that's why we have the offset, okay? And so in this, I will show you the other half here shortly. When you're looking at the rear main seal, and here's a photo of half of a rear main seal, you want to make sure that the groove, one side has a groove in it and the other side does not, okay? And you're going to want to make sure that the groove goes towards the inside of the engine, okay? And when you install these rear main seals, you do not want to use a lot of RTV, but you do want to use some RTV, okay? Make sure that you use just a thin film of RTV where the rear main seal half will contact the block or the cap, where where it's going to set in, because you want it to be secure. You want it to seal and kind of stick into place and not move around. And hopefully you're also preventing any oil from getting past it. But where you do not want any RTV is anywhere inside that groove that you can see in this picture. You don't want to have any RTV accidentally get into there, because that's going to prevent the seal from doing its job. And you also don't want to have any RTV where the crankshaft is going to be riding on the seal, okay? So very thin film, where the seal contacts the block, okay? And I mean really thin. That's important, okay? In this next picture, you can see the rear main cap. This is like cap number 5, the very backmost cap on the 390, and you can see that I have the offset seal is offset as well. So that you can kind of imagine, as the rear main seal, this block comes down, the rear main seal fits into place. So how do you know how much to offset? Well, I've heard 3/8 of an inch is about right, and I kind of just eyeball it. And I also try to install these seals pretty quickly, so I don't let my RTV set up too much. And that way, when I do set that cap down and I'm tightening it, the seal will kind of self-adjust if it needs to kind of move just a little bit, because I don't have the two halves perfectly offset. It will kind of move and adjust where it needs to be. So if you let the RTV dry and they're offset, then I guess you could potentially have a little bit of an issue. But I do it when the RTV's still curing, and it takes care of the problem. And you'll notice also, I think in some of the pictures, you'll be able to see that I use a little bit of RTV on the edge of the surface of the halves where they meet, okay, where the two halves meet together, just a thin film. So it kind of bonds them together as they come together, and hopefully are sitting flat on top of each other. So I hope all that makes sense. It's a little bit hard with pictures, but so this next picture, you can see that I have the crankshaft now sitting in the block, and that's all you got to do. Once the crankshaft is clean, you can just set the crankshaft right into the block, onto the main bearings that you have installed with the assembly lubricant on your main bearings that are in the block, okay? You just set the crankshaft down, and you can turn it by hand a little bit, and you know, it should spin real nice in there. Okay, this particular crankshaft, both the rod journals and the main journals of the crankshaft were turned 10 thousandths. So just, you know, just kind of being clear about what we did to the crankshaft. You can see they're nice and freshly machined. In this next picture, it's a little hard to see, but I'll show you a couple different angles here. We have the rear main seal that's in the actual block that's sitting underneath the crankshaft. You can see on the left-hand side of the picture, the offset is it's sticking up out of the block, and on the right-hand side, there's kind of a void there. And of course, when I install the cap, that void will get filled by the other offset side of the rear main seal. So this next picture, you'll have a better angle. You can see here. Now I'm looking toward the back of the engine, and you can see the offset there just coming up. So it's like about 3/8 of an inch, something like that. So anyway, that's kind of how you install the rear main seal, or that's how I install a 2-piece rear main seal. I do an offset, and I use a very thin layer of RTV. I don't use a lot of RTV on the rear main seal. I don't think it's necessary, but this is a 2-piece, and you do want to be careful when you install it. Okay, what you're looking at is the thrust bearing, kind of from a helicopter view. The crankshaft is sitting in the block, and I'm looking straight down on the third main bearing journal, right in the middle of the crankshaft, and I have these arrows pointing out where you want to take some measurements. Okay, so this is an important measurement to take. This is what's called crankshaft Endplay, and the crankshaft should move forward and backwards, even when it's fully installed. It should move forward and backwards, and sometimes people kind of like tap them with a mallet and stuff like that. But I take the measurement twice. I take it right where like it is now when the crankshaft's installed without the mains, and then I measure again when the main cap is on. But what you're looking for is you want to have enough clearance so that you know when the engine's running, the bearing or the crankshaft can move forward and backwards and not grind into the thrust bearing and cause a big problem. So the skirts on the thrust bearing provide kind of they keep the crankshaft where it needs to be, but you got to have clearance. Okay, so what you're looking for is like 7 thousandths to 14 thousandths clearance here. Now the sweet spot would be like 9 or 10 or maybe 11 thousandths. Okay, that would be like the sweet spot, 9 to 11 thousandths, and that's what you're looking for. Now remember, when you're taking that measurement, and you can see here in the next picture where I'm taking the measurement, you want to like force the crankshaft all the way forward or all the way back and create a gap there between the thrust bearing and the actual crankshaft. And then when you see that gap, you're going to measure that gap. Now here on my filler gauge, you can see I've got like 9 thousandths, 0.009. If you kind of cock your head, you can read it. And so there's 9 thousandths of clearance. So I'm pretty happy with that. It's like right where I want to be. But now for me to measure the on the opposite side of the bearing, I'm going to have to then push the crankshaft in the other direction to create that space on the other side. Okay, you don't want to have a gap. You don't want to have a 9 thousandths gap on both sides, like at the same time, because that would be like 18 thousandths clearance, right? Not 9. So 9 is the total amount that you have when you create that gap by pushing it all the way forward or all the way back. So I hope that makes sense to you. Now, in this next picture, what you can see is that I'm actually showing you the measurement of Plastigauge. Now, I use Plastigauge. I measure my journals and my bearing clearances in various ways using instruments, and that's great. But a lot of the people that use my videos to build engines, they don't have all the tools and the equipment. So they're like, hey, can I use Plastigauge? Yes, you can. Absolutely. It's not as 100% gospel or accurate as tools. other forms of measurement, but it certainly is a good guide, okay? So what plastic gauge is it's wax that you put down on a dry journal and then a dry bearing surface, and you torque down that main bearing cap or rod cap, depending on what you're measuring, and you torque it down to spec, full spec, and then you take it apart and see how much that wax got squished down. In this particular case, on this main bearing journal, I had almost 2 thousandths clearance. Now, the minimum spec on this Ford 390, minimum spec is 1.5 thousandths. Now, in my opinion, 1.5 thousandths is a little bit tight for a main bearing. It's great for a rod bearing, but it's a little bit tight for a main bearing. So I'm happy to see close to 2 thousandths here, especially in this application, okay? Because this is a low RPM truck motor. You know, it might see, 4,500, maybe 5,000 RPM if he was really just flooring the heck out of it, trying to pass somebody or whatever, but probably not. It's going to probably be like a 4,500 RPM engine. So, I think it's going to be perfectly happy with even just under 2 thousandths clearance. Now, if this was a high performance application where I'm going to be spinning some serious RPM, 6,500, 6,800 RPM, something like that, I probably want to have a little more clearance on the main bearings, maybe 2.5 thousandths, maybe 3 thousandths. I personally wouldn't use any more than 3 thousandths clearance on a main bearing, but 2.5 I'm really happy with. This particular case, I'm comfortable with just under 2. It's within spec, and given the application, I think it's going to be just fine. Okay, so that is a little bit about plastic gauge. You do have to check every journal, okay, not just one. You can't assume that they're all the same. Got to measure. If your machine shop did a great job, they all should be the same, but that's a variable, right? So you don't want to overlook a variable and then have an engine failure or problem down the road. So that's a little bit about using plastic gauge. Again, I know these are just photos that I'm using, and we're going to get back to using some video here pretty quick, but I wanted to do some explanation with these photos, and I hope that is helpful to kind of understand how some of this works. Unfortunately, I cannot find the video clip of me installing the crankshaft in the 390. I'm really disappointed. I guess I deleted the video clip at some point, and so I'm just going to have to use another engine as an example. So this is a Ford 289 small block that I'm in process of building, and so the nice thing about this comparison is that they're really identical when it comes to how they're set up, right? So a small block Ford and a big block Ford, they both use 5 main caps, okay? They all have directional main caps. They're all numbered specifically to the location that they should be installed. And both the small block Ford and the big block Ford use that 2-piece rear main seal, where the bottom half of the rear main seal is installed in the number 5 main cap. So, I mean, there's a whole bunch of similarities. So really, I should be able to explain everything using this as a visual. I am going to review all of the steps in order, kind of the order of operations, so to speak, after I get done with this quick explanation, okay? So when you're getting ready to install a crankshaft, and obviously you've installed the half of the main bearing set into the block, and you've lubricated those bearings. Then you've also installed the other half of the main bearing set into your main caps that you have, like, say, sitting on a bench somewhere. You've installed those and you've lubricated them, okay? The next thing that you'll do at that point is you're gonna wanna install the rear main seal half that goes in the block, okay? So I've already kind of covered that in this video already. So, but you're gonna wanna make sure that you do that. Because if you set the crankshaft in without the rear main seal in the block, you're gonna have a real hard time getting that rear main seal into place. So you wanna make sure that you do that before the crankshaft goes in. Okay, once the rear main seal half is in, once the half of the main bearings set, once they're all in, to their location in the block and you've lubricated them all, then you can set the crankshaft down carefully into the block, okay, where it should at that point stay. Now, what you're going to want to do at that point is you're going to want to take all of your main caps that you've installed bearings in and you've lubricated those bearings. You're going to set them in place. 1, 2, 3, 4, 5. You're going to make sure that they're numbered in order, okay? Now, as I get closer, all main caps are going to have numbers. And so this is very crude. That's a 1 and that's an arrow, but both the 1 and the arrow are very crude, but believe me, that's what it says, okay? It'll be a lot clearer here. As I move back, you'll see very clearly this is number 2 and a very clear arrow is an indicator that points towards the front of the block, okay? And then as I come back, you see number 3 with an arrow, and you'll see number 4 with an arrow. And then there is no arrow or number on number 5, but it looks so different. It's so, it's so specific, you really can't get that wrong, okay? So that's what you're gonna wanna do. You're gonna set all of those main caps in that order in place. And you can just tap them into place. You just set them down and you just kind of tap them. Sometimes you can push them down. Usually you just take a little mallet, rubber mallet or something and tap them into place, okay? Then you take all of your hardware, your main bolts or your main studs, and you're gonna, in this case, you're doing bolts. You're gonna take those bolts, you've lubricated them in an anti-seize, and you're gonna put them all in place. I usually run them down and then back up and run them down and back up without tightening them, just to kind of distribute that anti-seize in all of the threads and into the block and things like that. Okay, at that point, I'm gonna go ahead and start torquing down. Using a torque wrench, I'm gonna torque down all of these bolts. Now, as far as the order goes, first of all, I'm going to use like 3 different cycles. I'm going to do like 30 foot-pounds, 55 foot-pounds, and then like 80 or 85 foot-pounds, whatever the final torque spec is. I'm not just going to tighten it all the way to that torque spec. I'm going to go in like 3 different steps. And as far as the sequence goes, well, I start in the center and I work my way out. Okay. And so like, for example, I'd start here, 30 foot-pounds, 30 foot-pounds, come out here, 30 foot-pounds, 30 foot-pounds, come over here, 30 foot-pounds, 30 foot-pounds, go to the back, 30 foot-pounds, 30 foot-pounds, go all the way to the front, 30 foot-pounds, 30 foot-pounds, and then I'm good. At that point, I'm gonna spin the crankshaft. Okay, I'm gonna grab the crankshaft and I'm gonna start spinning the crankshaft, and I'm gonna see to make sure the crankshaft is spinning freely and isn't getting caught up. I don't feel any feel it getting caught or any catches or anything. It should spin nice, okay? Then I'm gonna go to my next torque value, say like 55 foot-pounds, for example, okay? 55, 55, 55, 55, 55, 55, and so on till I get 55 foot-pounds on all of the bolts. And then again, I'm gonna go back to my crank and I'm gonna start spinning it. I'm gonna make sure that I can spin it. Again, all my bearings are lubricated, so I'm good. I'm spinning it and making sure it's not getting caught up. Finally, I'm going to go to that final torque value of like 80 or 85 foot-pounds or whatever it is, and I'm going to make sure that all of those bolts are torqued to like 85 foot-pounds, and then I'm going to spin the crank again, okay? And I'm going to spin the crank all the way around several times, and I'm going to make sure that I feel really good about the crankshaft and how it feels. Okay, now the crankshafts are heavy, so they are going to have some resistance when you spin them, but they shouldn't be like really difficult. And I'm doing this by hand, right? I'm doing this by hand. This is not that hard, okay? If you use a bolt on the snout of the crankshaft and you're using like a ratchet or a wrench, it should be even easier, okay? So you definitely want to stop everything if this gets, seized up and you can't turn it. That's an indication of a major problem. You could have a crankshaft that's not straight. You could have one of your bores, that's off. Something's not right. So make sure your crankshaft spins smoothly. Okay. So that is the basics of installing a crankshaft. Now you do want to use a torque wrench. Okay. So in this case, I have a digital torque wrench. This one here is it's a lower budget digital torque wrench, but it works great. And you can use a torque wrench like this, or you can use a torque wrench that clicks. You can even use a needle style torque wrench. As long as you can get to that 80, 85 foot-pound, value, then, that's fine. And you can, as long as you feel like you can trust that torque wrench, then you're good. Okay. So I'm going to go ahead and put up the list of the steps that you want to take when installing a crankshaft. Okay, so we're getting ready to install these pistons. This here happens to be piston number 7. I've already installed a few of the pistons, so but I wanted to quickly just go over a few basic things because I think this is really going to be helpful for people who have maybe never installed piston rings on a piston and just need to know some of those things that can be confusing. So you have 3 piston rings, but it's actually more, right? It's like 5 because the 3rd piston, or the bottommost piston ring set here, is actually 3 pieces. And then you have a center ring and a top ring. These are a very standard set of piston rings, but I'll go over some of the things that you need to watch for. First of all, you install the bottommost piston rings first, and the first thing you put on is this expander and this oil ring setup at the bottom of the piston. Again, this is the expander. Most of the time you can put this expander ring on either direction on the piston. It doesn't matter, but the instructions on this particular set actually does require you to install this ring where the gap, see the 2 ends coming together right here? They want that little arrow that's forming there to point upwards. So it's to be installed, here's the piston, upwards like this. I mean, obviously it needs to be on the piston, but those 2 ends that are coming together need to point up. I thought that was interesting because I've never had a piston ring manufacturer instruct to do that before, so that was a new one for me. But anyway, follow instructions, right? It's easy. So we're going to make sure we install it that way on the piston, and then you put that one on first, and then you put these these 2 smaller oil rings, and they hold that expander in place. And you're actually going to clock these gaps here. So like if you have your opening here, like here, and it comes together, you're gonna clock these kind of off to the side a little bit, okay? So that none of them are lining up. And then your second ring, none of the gaps are lining up. The second ring here, what you want to make sure on any piston ring is if you have a dot like that next to my thumb. If you have a dot or even a any sort of stamping on the ring itself, that indicates that dot or that stamping needs to go towards the top of the piston, okay? So we need to install that correctly so that this piston ring can scrape oil towards the crankcase and not up to your combustion chamber. And what that has to do with is the beveled edge on the ring, okay? It's designed to do different things depending on if the piston's going up or down. So make sure that you put your piston rings in the right direction or orientation. That's important. So dots and symbols go up towards the top of the piston, okay? And I'll show this when I install them. And then finally, like this top ring here, you can see it's smaller than the second ring. This one here actually doesn't have an orientation. This one here you can put on either way. There's no bevel. That actually does have a slight beveled edge, but they're identical on both sides, and we're not worried because there's no dot, there's no symbol. They can go either way. What I was worried about, and you can see a little bit of some little marks here. I had to grind just a little bit, take a little bit off of this particular top piston ring to get the desired gap that I wanted in my bore. Because this is a hyper-eutectic piston. And so these came in about 22 thousandths before I did any removal of material, they were like 22 thousandths, you know, something like that. And now they're at 26 thousandths, something like that. And the reason that is because high protected pistons get hotter up top, and that means that the ring is going to get hotter. And so if they butt together, you can actually put pressure on the top here of this ringland, and it'll break. So you have to make sure your gaps are correctly, especially when you're using high protected pistons. Anyway, so this is any direction you want. This one here is directional with the dot, and then of course this expander ring is also directional, even though that's pretty rare. So we want to make sure we put them on correctly, and then of course you want to have these two gaps like opposite of each other on the piston. So you don't want these gaps lining up when they're installed either. Okay, so those are some basics of piston rings. All right, basics of piston rings. Okay, first things first, oil expander ring is put on, and notice on this particular one I have those two ends pointing up. So they kind of form an arrow and they come together like that, and that's what the manufacturer is recommending. So that's what I was talking about in the previous clip. Okay, now I have the bottom oil ring below the expander ring, and you can see my gap is about here. They come together there. I might slide this over some, like over here. But anyway, I'm just letting you know that you want to put that bottom ring on below the expander, and then put the oil ring above the expander next. Okay, so this one is on. So again, here's where the two ends of the expander come together, and then here's the bottom oil ring below the expander. There's the gap, and then if you come across or around here, there's the other gap right here. Okay, but it's up top right there. So now all those gaps are separated per the instructions, and you can also see that this is. Let me get in focus here. That's much better. You can also see that this is floating around really nice. That's what you want. And you also want to make sure that these don't ever overlap each other. They can, just by nature, they can overlap each other, although it wouldn't move around like this nicely if that was the case, because they'd be stacked, and then one would be rubbing up on the top of that ringland. So anyway, this is what you want when you first started installing your piston rings. And now I can move on to the second ring. I also want to mention that you need to be careful, especially with these top two rings, because they can break. Now, there is a tool called a ring expander that you can use, and you know, that's not a bad idea. In fact, it's recommended. Usually they don't want you to spiral these rings like I am. So if you notice, I have down there, I have it started right there, and then I have a slight bend in the piston ring. Now, this is a very minute bend, believe it or not. I'm not really stressing the ring out, but I could. If I lifted where my thumb is touching, if I lifted that up like maybe an 1/8 of an inch or a 1/4 of an inch, you would start feeling like I'm stressing the ring out. That's not good. So I want to keep this where my thumb's at. I want to keep that part of the ring as close to the piston as possible as I kind of work it around and bring it around the other side. So just be careful. You don't want to spiral your rings and cause stress. You certainly don't want to misshape them, and you don't want to break them. That would be the worst. So piston ring expander, good idea. But if you're experienced and you have a steady hand, you should be okay. Okay, the second ring is almost installed. I took a break real quick so I can show you. Notice I do have that dot facing up. Okay, so that's really important. And then as I walk around, you can see it's not quite, this is not installed yet, okay? But notice how this is part of the installation, okay? There's a slight spiraling, just barely, of the second ring. And then I have it just resting right here, almost, let me get you a better shot, almost ready to slide down carefully into the second groove here, okay? I also want to be careful that I don't scratch the heck out of this aluminum piston, okay? So as it comes down, I want to pull just a little bit out this way so I don't scratch the surface and make a big mar coming down on the piston, okay? So that's just, again, a little bit more information on installing these piston rings without an expander. Okay, now I have the second ring fully installed. Again, notice the dot is up facing the top of the piston, and you can see now I can actually work that second ring in there. Now the gap is huge right now, right? I mean, they got a 1/2 inch gap, but that's okay because I'm gonna use a tool that's gonna compress these rings inside the ring lands when we install into the cylinders, okay? And that gap's gonna get really tight, even tighter than that, okay? So anyway, so these should just kind of float around. You shouldn't have any burrs, okay? If you do any sort of grinding or material removal on the piston rings, typically you don't have to do it on the second unless your piston ring kit is designed that way or it's intended for you to take some material off. But you still want to check them in the bores, okay? And if you do, make sure that you deburr the edges where you removed material, because you will have a burr. And then when your piston ring is installed, it won't slide in and out like it's supposed to, and it will actually start scraping on the inside of the ring land, and that's not good, okay? All right, so now we're going to go to the easiest ring to install, which is the top ring. Okay, so the top ring is now installed, and I have the gap on the absolute opposite end of the piston. That'd be 180 degrees opposite. So the two gaps are away from each other completely. And you can see that I've taken some material off this top ring, okay? But I've also deburred the edges of that ring so that it moves around inside the ringland really nice without catching up at all. And so I'm real confident that's gonna be okay. Again, big gap right now, but that's gonna just kind of close up as the piston goes into the cylinder with the ring compressor, and then it will stay where it needs to be. The gap will, and of course it will expand as the engine gets hotter, but we have enough gap here at 26 thousandths on this 390 Ford so that I'm not going to have any budding problems where I could potentially break a piston, okay? So you do have, there's some things to know when you're installing and working with pistons. So next we're going to talk about a few other things that you want to definitely do when you're getting ready to install these pistons. So I'll talk about that next. Okay, so now our rings are all put on and installed correctly onto the piston, and they're oriented correctly. I'm going to be using this piston ring compressor tool to compress the piston rings into the ring lands so that I can install into the cylinder. You're going to need something like this if you're going to install pistons into an engine block. The other thing is that if you look up here, my rod bolts here don't really have, they have a light oil film, but they don't have any anti-seize. So we're going to be putting some anti-seize lubricant on them prior to installation. And then of course, I'm also going to be putting bearings into both the rod end and then the cap end as well. So we're using a real standard Malley or Clevite. I guess they're the same company now. And so here's the bearings. Now the crankshaft that I'm using on this 390 has been turned and polished, and it's been turned 10 thousandths. So the journals are 10 thousandths smaller than they were when the crankshaft came from the foundry. And so I have to use a bearing that is 10 thousandths thicker so that they're the right clearance, have the right oil clearance. So you can see here, these have a -10 indicating that they're 10 thousandths thicker, I guess you could say. And so to make up for that extra machining on the crankshaft. So I also want to check and make sure, they say the Clevite here, but in the 77 series, but on the other end, you can see where it says 0.010, that's 10 thousandths, okay? And you want to check to make sure both rod bearings have that same spec, and just in case someone boxed them wrong. Okay, now you're gonna, like I always check, of course, the measurements on the journals, and then the inside diameter as well, when these are in the rod torqued down. So you have to check your specs, but also look for the obvious stuff, right? When you can. Check for the obvious mistakes. And so that would be definitely one of them, is having a mixed match or wrong sized bearing set, okay? All right, so we're gonna go ahead and install these. And to do that, what you're gonna do is you have on both just like the mains, you have this little indentation where this tab goes in here. So you're gonna set that in place, okay? So it's just barely sitting there, okay? Move this over, it might be easier to see. And then you just take your thumb, now look at the gap here, I have this major, space here. You're gonna just take your thumb or whatever, I'm doing this one-handed, and you're just gonna press down with your thumb. Never in the middle, this is bad, okay? But on the edge, outside edge here, you push down until you have both ends of the bearing are flush with the cap, okay? So, and you never wanna have any lubrication underneath the bearing, okay? It should go on the cap dry, and then you can lubricate the top side of the bearing where it's gonna be contacting the crankshaft journal. Okay, we're gonna do the exact same thing for this section of the rod, the actual rod itself, and then I'll go over anything else that I can remember that you should know. Okay, so now you can see I have the bearing here dry, but the bearings are installed properly into the rod, both ends in the rod, and I've also put my anti-seize on my rod bolts here. Something else you want to do is the side of the nut that goes onto the top of the cap. You want to make sure that you also have lubrication there, because that's rubbing, unless you have a washer. And of course, if you did have a washer system, you'd want to put the lubrication on the washer and nut. But you want that lubrication to be in between the nut and the cap, and so that when you're tightening this down really tight to like 45 or 50 foot-pounds, that it's not grinding in hard, that friction. You're reducing the friction on top so you can get the proper amount of torque. You want to be able to kind of slide around and spin, okay? So it's important not just to have it on the threads here, but you also want to have it on, either you can put it on the top of the cap here, or you can put it on the nut. But anyway, just don't forget that. And then the biggest thing that I should have mentioned that I forgot to, and this is really important, especially on a Ford. The rods are directional, okay? On Chevy, a lot of Chevy applications, the rods can go on the piston either way. Obviously not upside down, but I could turn this, all the way around and install it on the piston. Not the case on a Ford, maybe other applications too, but check this out. There is a beveled edge right here, okay? Big beveled edge. That beveled edge has to go to the outside of the crankshaft journal, not the inside. I have had 2 different occasions where machine shops have pressed pistons and rods together for me and put them on backwards, because at least on a few of the rods, because they were thinking, oh, it's like a Chevy. That might be a sign of either a really inexperienced employee, but it might also be just a bad machine shop you don't want to go don't want to return to. In my case, it was a good machine shop, but it was like an honest mistake. And anyway, but I've had it happen twice over the years, so be careful. Now go to this side and you'll see there really isn't a beveled edge, maybe just a tiny beveled edge, okay? This side goes on the inside and touches the other rod, okay? So it's super important to get that right. If you have these rods installed incorrectly, if this rod was flipped around on this piston, then what you'd have to do is you'd have to have the arrow pointing towards the front of the engine, pointing towards the back. That's not good. And also, sometimes pistons, the top of the piston is designed like this one is, but even more so to go in a certain direction because maybe you have a bigger intake exhaust recession. You might have a bigger intake valve recession or relief than you do an exhaust, and vice versa. So you have to be really careful with this, okay? Make sure that your rods are installed correctly on the piston, and make sure this beveled edge, no matter what engine you're building, check and see, because these rods can be directional. And I know on small block and big block Fords, they are absolutely directional. So be careful with that. That is definitely a mistake that you don't want to make. If you did make that mistake and you weren't aware of it, the Endplay, or actually you call it Endplay, the plate in between the two rod, big ends in the rod, is going to be very insufficient. You're not going to have a lot of play there for them to move back and forth, and you want there to be some play there. So when I get back over to the engine, I'll shoot a little clip of the play that you're looking for there, and you definitely want it, or you're going to have some problems. You're going to have engine failure is what you're going to have. So anyway, all right. So those are some things that you want to pay attention to when you are prepping your pistons and rods for installation in your block. Oh, and one last thing. I use 3/8 fuel line. I've been using these pieces for like 20-something years. You just take these pieces of fuel line, 3/8, and you slip them over the broad bolts, okay? And what that does for you is when you're installing the rod down in through the bore and it gets close to the piston itself, you're not gonna mar the piston. It also helps guide the rod down and onto the journal of the crankshaft as well. But now we're not going to damage the crankshaft journal, and that's really important. Okay, the last thing I'm gonna do is I'm gonna lube up these two bearing halves, and I'm gonna install the piston in the block. Okay, before I go over to the block to install piston number 7 here, I just wanna point out that I have my piston ring expander tool installed, and you can see that this band is pressing in all of the rings, but look how pressed in those rings are, okay? So now those rings, instead of hanging out the sides of the ring lands, they're pressed into the ring lands, and that's gonna allow me to tap the piston in. And these are pretty flat, just barely have a little bit of an edge, okay? Just barely. I might try to squeeze these handles a little bit more and get one more click out of it, so that I maybe have less of an edge there on on those oil rings down low. But anyway, so that's that. And then I probably also failed to mention, you want to make sure when you install the caps, look for the stamping on the cap. This is the wrong side, of course, right? That would be too easy. Flip it over. There we go. So notice there is a 7 stamped in here for cylinder number 7. When I put this rod on, I want to make sure that I'm matching up, again, wrong side, because that would be too easy. There's number 7, see it? Okay, you want to match the two 7s together, and that's going to make sure that beveled edge of the big end of the rod is in the correct location. If they install the rods on the pistons right, it's gonna ensure that beveled edge is on the outside of the rod journal on the crankshaft, so you have the proper play between the two big ends of the rods on that journal. Okay, that's it. Hope that makes sense to you guys. And now I actually am going to go over to the block. All right, here we are on the driver's side of this 390 Ford FE big block. The front is over here. You can see the snout of the crankshaft. And then over here we have cylinder number 7, piston number 7. And notice the arrow again is pointing towards the front of the engine. Even though my 30 over stamping is upside down, that doesn't matter. It's this arrow that matters. And again, I'm going to show you, once I get this piston down into the cylinder, I'll show you how it matches up to the other rod on the journal when I flip the engine over. Okay, so now I'm just going to use over here, I'm going to be using a rubber mallet to tap this down as I hold the ring expander band flush with the deck of the block, and I'm going to get it so it slides all the way in by just tap, tap, tap. And it doesn't take a lot of power, So, you know, you can't be real weak like this, but you have to actually give it a kind of a little bit of an actual tap, but you want to use something soft. I've used wood before, like a wood handle of a hammer, but sometimes you can get this splinter. So something rubber like this is nice to use. Okay, so now I'm going to go ahead and get this thing inside the block. All right, we'll see if I'm savvy enough to do this one-handed. Here we are. We have, you can see these are the rubber fuel lines that are protecting the crankshaft journal from the rod bolts. And so as it goes up, you can see I have plenty of lube on the journal. And what I'm doing now is, if I can do this, I'm gonna tap so that the cap, excuse me, not the cap, but the rod itself goes onto the journal, okay? And it does a little self-correction there, bam. It's very shaky, I'm sorry. But now I just tapped it and it goes right into place. And now I can remove, trying to watch the video camera, it's not probably a good idea. So now what I do notice right away though, is I did have just a little bit of bearing slip right there. And that's okay. I'm just gonna slide that bearing back down very carefully with like a plastic tool that won't mar the journal, and it will slip right back into place, and I'll be ready to install the rod cap. But when I do, I want to make sure you guys can see that I'm going to have the right amount of play in between these two rod ends, okay? There needs to be play here. If not, you're going to have a problem. So I'll show you that when I get the cap installed. Something I like to do is just keep all of my piston rings specific to a cylinder. And so when I'm gapping, checking the gap and adjusting the gap, especially on that top ring when you're using a hyper-eutectic piston, or if you buy a piston ring set that's a file to fit, where you actually have to file your piston rings to fit, you're gonna wanna make sure that you keep them separate for each cylinder so you know your measurements stay true from one cylinder to the next. So you can see here, I've already installed 1, 3, 5, and 7, but you know, I'm keeping them all separate, and so now I know for sure that those piston rings are gonna fit those bores perfectly. So just a good idea, little tip that you might wanna try out. So the bottom end assembly is all completely installed, and I've checked all of the specs, all the oil clearances, bearing clearances stuff. It's all good. Just to kind of give you an idea, if you're building an engine, I had 2/1000 clearance on the mains, which is a little tight, but I am running a full groove bearing, so I'm okay with that. If you're running a full groove bearing and you have a big oil clearance, you'll probably lose a significant amount of oil pressure. So with the full groove bearing and 2/1000 clearance, you know, I think it's going to be okay, especially a low RPM engine like this. This engine probably won't see more than like 4,500 RPM. It could handle going higher than that, but just with the cam selection, it just probably won't. And then on the rods, had a little bit less than 2/1000 on the rods, which is fine, totally within spec. And it was pretty consistent. So very happy. One of the things I did want to talk about real quick is Endplay. Lots of people overlook Endplay. So the Endplay measurements, or what Endplay is, I should say, is Endplay is the ability for the crankshaft to go forward and backwards, okay? It's also the ability for these the big end of the rod on the journal to go forward and backwards in relation to the journal and, of course, the two themselves, the two rod caps. So you want to be careful to check those. Now on the crankshaft, you check the Endplay by taking a filler gauge, and you're going to slide the filler gauge in between the thrust bearing and the crankshaft on both sides of this number 3 cap or bearing retainer, okay? And so you can see where there's a very small amount of room there. You can also, and you should, tap the nose of the crank and the back of the crankshaft, and you actually should be able to see the crankshaft move just a hair, right? Forward and back as you tap on those respective parts of the crankshaft. And then you'll be able to measure, and you'll create a gap. So for example, I tap the back here with like a rubber mallet, heavy rubber mallet, and then the crankshaft goes forward, and then I would test that gap. And then I would tap the nose of the crank to force it backwards, and then I would check over here for a gap. And what I had was about 10 thousandths. So I was happy with 10 thousandths. Spec on this is somewhere between like 6 and 14 thousandths, and so 10 is great. So 10 was good. And then as far as the rods go on these big ends, again, you're looking for definitely some movement, which I have. And in fact, I'm going to show you. It's really easy to see here. And of course, because it's not that heavy, I can move it with my hand. You can see the gap. See the gap? Now watch. I'm going to close it. See it's gone. And now watch. I'm going to make it reappear. There it is. And then it goes away. Okay, that's in play. And you're going to have that gap here and in between, and then on the far side here. And so you can take, in this case, I have a 12 thousandths filler gauge. It's 12 thousandths thick, and I can create that gap, and I can slide it in here, and I have, it's actually probably more like 14 thousandths, because this is going in fairly easy, but I do feel a little bit of friction, just a little bit, okay? So, and I can do that here, and then move it, and I can do it here. Let me move this just a little bit more. There we go. And then I have it here, and then I slide this one over, and I have it here, okay? So that's what I'm looking for in play on all of these rods on these journals. Now, like I had mentioned earlier in the video, Ford rods are directional. And so you wanna make sure the rod is installed on the piston correctly. And if you make sure that the rod is installed correctly onto the pistons, and then you install the pistons correctly, you should have the proper in-play on the crankshaft. It's usually when someone has a machine shop or they do it themselves and they install the rod incorrectly onto the piston, then they don't fit right, and you'll have actually no in-play or very, very little in-play. And then you have, it's going to build up heat and friction, and you're definitely going to have a engine failure. So anyway, that's a little bit about in-play and a little bit about this this engine that used to be a 360 and now is a 390. All right, here we are getting ready to install our timing set on our Ford FE Big Block 390. And there's a couple differences and variables that you might encounter. So I'm going to kind of just talk about them a little bit. So first thing, you can see I don't have my pin, my little dowel pin that sticks out of the camshaft here. That pin keeps your cam gear phased correctly on your camshaft, and so it's important that you run one. Very important, but there's two different links, and depending on what setup you're running with your with that timing set, as well as the Eccentric, that's going to dictate which length pin you run. So let's come over here. So I'm running a 2-piece fuel pump Eccentric on this setup, and so I'm going to need to run the shorter style pin. Okay, and the reason that is because when the cam gear fits on like this, okay? And so that pin, of course, is gonna run through this smaller hole in this timing gear. And the longer pin, what the longer pin would do is it would actually take up all of this space here, kind of like that, okay? If you install the longer pin and this timing set, you'd be like this. And if you weren't running a fuel pump Eccentric, that would be okay, but I am. And so what this tab here needs to do is it needs to fit into that hole, okay? Like this, and then your cam bolt rather, runs through like this, okay? So you can imagine if you didn't have any space here, if it was completely occupied by that cam pin, then that tab wouldn't have any place to go, all right? So now, if you are running a 1-piece Eccentric, then you need to use the longer pin, because the longer pin is actually going to come through an opening on this Eccentric, and it's going to keep this Eccentric in the proper location. So the short end of it is, if you're using a 1-piece Eccentric, use the longer pin. And if you're using the two-piece eccentric, you're gonna need to use the shorter pin, okay? So that's the first thing I wanna point out on this setup. The other thing is that the original, a lot of the original engines, they would actually run a washer that would go right here, and it had a split in it. It was a fat washer that had a split, and so the split would be to go around the pin. Okay, so just imagine a washer with a little gap, and the gap goes where the pin is, and then that would keep the proper space between the camshaft itself and the backside of this cam gear. These newer setups, and I don't know if a certain year Ford changed it or if just the aftermarket has changed it. I don't know the answer to that, but if on the backside of your cam gear you have, if it's raised like this, that is taking the place of that original washer that used to be needed. Okay, so if you have this raised area here on the backside of your large cam gear or the larger gear in the timing set, then you no longer need that washer, and that's really important because you wouldn't want to try to run both. Okay, so that's something I would like to point out because I had to look that up myself just to make sure I wasn't doing something wrong. All right, so I know I'm getting close to 5 minutes here on this clip, but what I'm looking at here is the first thing we're going to do is we're going to be using a plate like this. Okay, the cam plate is going to be put into place and it's going to be bolted down, and that's going to assure us that our camshaft can't come forward. Okay, so that's the next step. Okay, we're going to be putting this factory plate installed like this with some bolts. All right, now that we kind of know about what length pin we're going to run based on the eccentric we're going to be running, now we can really start to install this. The first thing we're going to do is we're going to want to install the retainer plate. Now, small block Fords and big block Fords run a retainer plate, and what it does is it keeps the camshaft from coming forward too much. Okay, so right now I already have the cam run forward. It's brought forward about as far as it's going to ever go or want to go, and that's going to align the cam lobes with our lifter bores so that the lifters can ride on the cam lobes in the correct location. We're going to run this retainer plate right here, and this little groove, it goes towards the front. That needs to, you still, basically when you install this, you still want to be able to see that, okay? And then these are our two bolts. I'm going to go ahead and put that in place here, and then I'll continue the video, and I'm going to show you that you want to make sure that you have the proper clearance between the heads of these bolts when they're fully installed and then the back side of this cam gear here. Okay, that's going to be really important. And also those two bolts that we're going to be using, these two here, I'm gonna torque them down to about 25 or 30 foot-pounds. They're much larger than the small block Ford bolts that you have to be really careful with because you can just break the heads right off of them. Those small block Fords, I think they're like 12 foot-pounds or something like that. They're really hardly any torque, but these here, like I said, 25, 30 foot-pounds because they're a much bigger bolt. So that's how I'm gonna run. And then the main cam bolt here, you can tighten down to like 40, between 40 and 50 foot-pounds, you should be okay. That's what I'm gonna be doing next. So I'll go ahead and kind of get this mocked up and then I'll come back and show you what it looks like. Okay, so this is the cam retainer plate installed on the block, and if you're observant, you're going to notice that I have a washer here, and I don't have one here. And that kind of bothers me a little bit because I like things to be uniform, but long story short, I'm using a bolt that is not the factory style bolt that was used. The factory style was a Phillips head, and number one, I don't have them, and number two, a lot of guys will recommend going to a bolt because you can torque them down a little easier. The concern, of course, is that these protrude forward more than the original Phillips head would, and that they might contact the backside of the cam gear. So you have to be careful with that. So I decided to use these extra thin washers. These are 40 thousandths thick, which is pretty thin actually. And so I ran them in both locations, and this one here actually, this not the washer, but the actual head, one of these corners was barely, and I mean barely rubbing the inside of the cam gear. So couldn't have that, of course. So I went ahead and removed it. I still ran this one though, because this bolt didn't sit flush against this cam retainer plate without a washer there. And on this particular bolt, there's no contact. You got tons of room, like over 100 thousandths clearance. I mean, it's like lots and lots of room. So even though it's not uniform, I don't like it because of the way it looks. You're never going to see it, and it's not something that I think is going to be a concern. They're both torqued down nice and tight. They're not going anywhere. They both have clearance now. Having a washer on this side of the retainer plate doesn't cause any problems because the retainer plate is sitting flush against the block doing its job. So again, I'm satisfied. It's going to be fine. I don't know. I've really thought it through quite a bit. So just a special note, you see this little mark here. You're going to want to make sure that's facing forward. In fact, it's going to be hard to get it to fit without that being the case. But anyway, that is the proper location and orientation of that cam retainer plate. I've also installed the short pin. Now, the short pin, this particular short pin, it was a little tight fitting in this into the bore here that it goes into. So what I had to do is I just took some sandpaper. I put this in actually in a drill, and then I took sandpaper. I used like 150 grit, then 400 grit, and then like 1,000 grit to polish it up really nice. And then I was able to get it to slide in. It's still a little snug, but it slid in properly. So that's that. So that is the cam retainer plate. It is installed now. That's what it should look like. Now you kind of know why I have a washer in one location and no washer in the other location. And I'm satisfied, and I think it's going to do the job that it's supposed to do. So moving on. All right, now that the cam retainer plate has been installed with the two bolts that I talked about, and I've torqued that down to between 40 and 45 foot-pounds, although you probably could get away with a little bit less. I have the timing gears and timing set mocked up. Now it looks like it's installed, but it's really not. For instance, you don't see the Eccentric installed, and I am running a mechanical fuel pump. So I'm gonna be putting an Eccentric, that two-piece Eccentric on. So this is just actually kind of sitting there. It's not tightened down yet. But I wanted just to kind of mention something. So again, we want to make sure when whatever bolt you use, that you are not going to have any clearance issues between the back side of this the cam gear. Okay, on the back side, you want to make sure that bolt right there, that one right in there, that is not going to grind on the inside. Now you can kind of see that bolt through these little windows, and you can kind of get an idea whether you're going to have an issue or not. Like I said, when I put a washer on that bolt, I did have an issue, whereas I did not on the other bolt that you can't see because it's behind here. But you do want to make sure that you're really comfortable with those two bolts and the clearance that you have on the back side of this cam gear. I also installed that pin. Now that pin is actually, as I tap this or I tighten this, and that pin is going to come forward inside of this gear, but it's going to still give me room for the tang on this Eccentric to slide in and stay in place. Okay, and I'm gonna have to obviously remove this bolt and washer before I put the Eccentric in, but I'm just telling you, you want to make sure if you're running an Eccentric that you have a two-piece, that you have room for that tang to fit into this hole. Otherwise, it's going to sit cockeyed and not flush. Okay, anyway, so that's just a couple of things. Now, when you're installing a cam gear, when you're installing a timing set, first thing before you even get started, you want to make sure your number one cylinder is at top dead center. Okay, so piston is at top dead center. If you want to know, this piston's sitting about 5 thousandths below deck, which is fine with me, and that's where it is, and that's important. You don't want to install a timing set with the piston anywhere other than top dead center. And I've already checked. This is cylinder number one here on the passenger side front of the block. So now I want to make sure that I align these two dots, okay? So these two dots need to be aligned and very close to each other. They should be perfectly up and down from each other, okay? And that along with the piston at top dead center is going to allow you to know that your timing set has been installed correctly and your engine will run properly. So I'm going to go ahead and start tightening this down, pushing this timing gear back, having the pin come forward, and then I can remove the cam bolt and install my eccentric, okay? So that will be complete after I torque this down to like 45 foot-pounds. That's going to complete the install of our timing set. Okay, so now I have the timing set installed so it's all the way back where it needs to be. The cam bolt is out, and I'm gonna test fit this this eccentric. Now again, this is a two-piece, but I wanna make sure this tang is gonna fit into the hole. And you can see now, you can actually see the pin from the camshaft coming through, but again, I have a space there, you see? I've got this space for this tang. All right, we're gonna talk about that in a minute. I also wanna point out, and it's hard to see, but I do have, there you go, you can see, I hope, right here, I actually have a little bit of daylight, okay? And now where you're seeing that daylight, that little gap is not the actual clearance. It is clearance, but there's even more than that, okay? So I'm really confident that this bolt here is not going to rub on the inside. You know, whether, even if this large cam gear, it's all the way back now. So it's only gonna move forward a little bit during engine operation. Obviously it's gonna go back and forth just a hair. But even in the position furthest back against the block, it doesn't touch this bolt. So I'm very confident that I got the clearance. And again, that's important because that's the little stuff that causes problems, okay? Now let's talk about this eccentric. When I put the eccentric in place, I noticed immediately it doesn't feel right. So if I come up here and show you, look at that gap. So the pin that I used, the cam pin that I used, that dowel, it is too long still. But fortunately, it gives me enough room in here. That's quite deep. So I'm gonna just shave a little bit off of this tab, this tang, and then it's gonna fit flush against the cam gear. So that doesn't really bother me. That's just a slight adjustment that I'm gonna make with a grinder. And then I'll clean it up so it doesn't have any debris on it, and then put it back in place. So anyway, these are just the little things you have to do and check. It's nothing you know, hard, but you want to take your time, okay? But look now, I got these two dots. They're just perfectly lined up with each other. And then I've got the cam, you know, the timing set, that double roller. It's nice and even up and down, okay? And again, I think it pistons at top dead center. So I'm liking how all of this is looking. Pretty confident with it. And now I'm just gonna make sure this eccentric setup is gonna fit properly. All right, what we have left here, as far as the timing set's concerned, is our eccentric. I haven't mentioned this yet, but just in case you don't know, the only reason you run an eccentric is to activate your mechanical fuel pump. If you're running an electric fuel pump, you don't have to run this at all. You can just run the cam bolt, okay? This is strictly so your mechanical fuel pump will work. So this is a two-piece eccentric like we've already gone over. This piece literally just slides, center piece slides right into the other hub. Okay, we're gonna run our bolt into the middle, just like that, okay? And then that tab, I've already made it shorter, so it now fits into the provided amount of room that I have. You can see my cam pin there. I've got just enough room there. And I went ahead, I still have plenty of tang to go in. Start tightening that with my left hand here. Very impressive, I'm a right-handed person, okay? And then this tab, actually it's already fitting in there quite nice, okay? So it's gonna fit flush against the cam gear. And then once I tighten that down and torque the cam bolt down to about 45 foot-pounds, then the timing set on this big block Ford 390 FE is complete. We can move on to the next step. So getting there. All right, we've got this timing set fully installed. I'm excited about that. Again, we have the piston at top dead center here. We've got our two dots perfectly lined up. Keep in mind, all these engines are 4-stroke engines, so your spark plug only fires off every other time the piston comes to top dead center. So if I was to rotate this timing set clockwise, I would watch that piston go all the way down and then all the way back up. And then I would notice that this dot here is only up top. It hasn't gone all the way around. It's going to be 180 degrees away from where it is now. And then it will be the second time that this piston reaches top dead center that I'm on my compression stroke, the piston, the spark plug fires off, and you'll have these two dots aligned again. So just, keep all that in mind so you don't get confused. But anyway, as long as this piston is at top dead center, when you install this timing set dot to dot here, then you should be just fine to tighten it all down to spec and continue on with your engine build. So anyway, that's where I'm at right now. Timing set is installed on this big block Ford 390 FE. Okay, really quickly, let's talk about oil pump drive shafts. This shaft runs in between the oil pump and the distributor. So just so you know, if you run like a high volume pump or something that may put a little bit more stress on the shaft, you might want to go to an ARP, or heck, just go to the ARP shaft because it's not that expensive and it'll make you feel better. But this shaft is actually pretty strong. I can't remember if the small block Ford ones are thinner than this, but this one here is not flimsy at all. So let's talk about this little keeper and what it does, what it's for, and how to install it. So there's a lot of talk and misinformation about these. The way this is supposed to work is this little keeper prevents this shaft from coming out of the engine when you pull the distributor. Because if that happens, when you pull the distributor, let's say you've had the engine in your vehicle for quite some time and you go to pull the distributor for whatever reason, and this shaft comes up with the distributor and then it falls back down, you might drop it into the oil pan, or it may be difficult to get it back into the proper location on the bottom side of the oil pump. So what you do is you take this ring and I have the engine upside down, right? And you take this retainer clip and you're going to point it towards the top of the engine, going straight down, right towards that hole, okay? And it's just going to sit right here, just like that. And then when you install the oil pump, you'll make sure that this hex goes into the fitting right here in the oil pump. And then you'll notice that when you flip the engine back over, so it's right side up, the gravity will pull this into position, okay? And it will work correctly. And then it can't go anywhere because it's going to be kind of stuck between the oil pump and that hole there. And so then it stays into place and you don't have to worry about it going somewhere where it's not supposed to go. The other clue here is if you look at the very end, on the distributor end, as I'm calling it, you'll notice that it's pointed. And that's actually to help guide the distributor shaft down onto this oil shaft or oil pump shaft, okay? So it just kind of helps align things. So that's another clue. Whereas this side here is flat and just goes into the pump, okay? So there really is no mystery on how this works, but you could get it to work either way. It's just the headache of potentially having this shaft go where it's not supposed to go when you're removing your distributor down the road. So anyway, that's how that goes, and I'll show you a quick video once I have the oil pump installed so you can see what that looks like. Okay, now that I have the oil pump installed along with the pickup tube or screen, you can see that the shaft here is installed, and here I'll go from the back side. See how that moves up and down? That's awesome. Now the engine's upside down, So when I flip it right side up, this is gonna fall, just like that, okay? Because gravity is gonna bring it into position. And that's gonna keep that clip, that retainer clip, from grinding on anything, okay? So right now, the clip is resting on the inside of the block. That's not good, right? But it will loosely just fall down in use. Also, the distributor, when you insert the distributor is going to push that into position as well. And now, this cannot come out. This is a permanent installation unless you take off the oil pump, okay? Now, the oil pump, these two bolts are not factory bolts, but they're the correct size. They're a little bit longer than the factory bolt. So I went ahead and used some split washers on them. And these are torqued down to about 35 foot-pounds. And then these here are smaller bolts. And these are like 15 to 20 foot-pounds. Now, just so you know, there's a gasket in between the block and the oil pump housing. And there's also a gasket between the oil pump housing here and the pickup tube or screen, okay? Another side note is when you install these screens, you want to make sure that you check the final installation and depth of this screen, that it's 1/2 inch from the bottom of your pan. So if you have 5 inches between the flat surface of your pan rail and the bottom of this screen, if that's 5 inches, and then you go to your oil pan and you have from where it sits to the bottom of the pan 5.5 inches, then you know this is going to be sitting 1/2 inch from the bottom of your pan, and that's where you want it, okay? You can flex these a little bit for slight adjustments, but you don't want to move them too much. So you just want to basically make sure that they're not like 2 inches off the bottom of your pan, because then it can't even access a good amount of the oil that you have in the oil pan. So 1/2 inch keeps them from sucking up garbage that you might accumulate in the bottom of the oil pan, but it allows them to get to or suck from the majority of the oil in the pan. So just kind of keep in mind when you're measuring that up. 1/2 inch is what you're looking for, okay? So anyway, now we have the oil pump and pickup screen installed with the oil pump drive shaft. Okay, so normally at this point in time, I would install the front cover and then I would install the oil pan. Now you always want to install your front cover first and then your oil pan, because the front cover kind of completes the mating surface for the oil pan. And so it's important to install that front cover typically first. I can't do that though, because I'm waiting for my oil slinger. So the oil slinger rides on the crankshaft snout up against your lower crank gear here for your timing set, and its job is just to simply kind of sling oil up and onto your timing set to keep it lubricated. Okay, some people have gotten away without running a oil slinger, but you know, that's the way they're designed, and oil slingers can be found on just about a lot of the engines out of the American V8s, so, and probably others as well, but I know on my big block Mopars and stuff, they all have them. So anyway, you want to run the oil slinger. I don't have one yet, so we're going to hold off on the oil pan and front cover, and I'm going to focus on the cylinder heads. So I'm ready to get started with installing the cylinder heads, and one thing I want to mention is these head gaskets. So the important thing here is the orientation, and although it might be a little bit laughable that someone could install them backwards, because they're so clearly labeled front, it does happen. And it used to be a lot harder because the companies wouldn't label them front for you. You just have to know what you're doing or read instructions. And sometimes people just think, oh, look, I got it to fit, so it's gonna work. Well, you can put these on wrong, and that would be bad. So another thing on these Felpros, they have this like blue striped. One of your blue striped sides is gonna face up like this one, and on the other side, your blue stripes are gonna face down. That's okay. That's the way they're intended. Okay, so look, it says front. You'll notice the water passage is blocked off. And on the front here, the water passage is blocked off. That's the way it's supposed to be. And in the back, you have the water passage open. And what that does is it forces the water to flow through the entire block to the back of the block and cycle through the heads and intake. So just know that those back water jackets have to remain open when you're installing the cylinder heads, and that's how you're going to make sure that you have the correct orientation on your head gaskets. Now again, this is a Ford FE390, but the head gasket for the 390 and 360 should be the same, and this here is part number 8554PT, and I think I'm about ready to install these cylinder heads. I do have, I know what I wanted to mention. What's really cool about these old blocks, and this would be true with a Ford 289, but not true with like the newer 302s after a certain year, probably like after 86 or something. What's cool is that all of the holes for your head bolts are all blind, and what that means is that they do not go into the water jackets of the block. And if you take a flashlight and you look in every single one of these holes for the head bolts, you're going to notice that they absolutely have a bottom, and you can totally see where they bottom out, and that's a good thing. Now, just a side note, 289 small block Ford is going to be the same thing, but if you go to like a late model 302, like say out of a 89 Mustang or something, you are going to have the lower bolt holes are going to be open into the water jackets, and you have to run a thread sealer that won't allow your antifreeze or your water to come through and drip onto the ground. But these are all blind. I'm glad, because then I can just simply put on my anti-seize on my bolts, and I can run them down to torque sequence, and I'm good. Speaking of that, we do have the head bolts here. This is a very standard head bolt set, and you can see there's two different lengths on this Ford FE big block. So you're going to want to pay attention, of course, and then you immediately run into a problem if you put them on wrong. But you do want to make sure that the bolts are in the right location, and then use the proper torque sequence with your torque wrench to get the heads bolted on correctly. So we're going to go ahead and bolt on heads. I am going to use an anti-seize lubricant on all of these threads, and run them down and back again, just to make sure that they're going to torque to the proper spec and be uniform throughout the cylinder head and on both sides. So anyway, yeah, so we're getting there. We're going to install these cylinder heads and be one step closer to being finished with this Ford 390 FE big block. All right, now I've got a cylinder head that is sitting on the block in the correct spot. Remember, I have the head gasket on correctly with the front water port or jacket blocked off, and that's going to force water through the head. And also I have all of my bolts lubricated with anti-seize, and I've run them down, back up, and then back down, just to kind of get all that anti-seize in those thread pockets. Okay, so I have not torqued these down yet, so I'm going to talk about the torque sequence. First of all, the torque spec on these bolts is 80 to 90, so between 80 and 90 foot-pounds, and there's a sequence, very simple, on these Fords that have just 10 bolts. Okay, so what we're going to do is we're going to start here, and it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's the sequence you use on a big block FE Ford. And also keep in mind that you want to do that like in 3 steps. So I'm going to go like 30, 60, and then like 85 or something like that. Okay, so that's going to be my head torque spec and sequence, and that's what I'm going to be doing right now. So cylinder head on the driver's side is bolted on, and now I'm going to go ahead and torque it down. Okay, One last step, and that's gonna be 85 foot-pounds, and we're good to go. All right, here we are again. Gonna install the oil slinger that I got. Woo, finally. Had to track this down. This is an oil slinger off an FE motor, and you do want to run one. They sling oil on the timing chain, keep it lubricated, so don't run your motor without one. Very common to find oil slinger on V8s, probably other engines as well. But anyway, here's your key, right? And your keyway. So you want to make sure that you put it on properly. Don't put it on backwards. If you put it on like this and you slide it into place, you think, oh, cool, I got it right. I'm good, but you're not, because now you'd have the oil slinger coming into contact with the timing chain. That's no good. So when you put these oil slingers on, they are shaped so that they space themselves out. Now you actually have the correct space between the timing chain and the slinger itself. The slinger gets pushed up against the lower timing gear on the crankshaft, and then once your front cover is installed, you have this sleeve. This is a sleeve that's definitely a big block Ford thing. This sleeve here is actually going to slide, and it also has a keyway, okay, for this key. So it's going to go on like this, and it's going to fit into position. It's going to push when it's properly installed. It's going to push against the oil slinger and keep it in place so it doesn't move forward, okay? Then you have just enough room here on the snout of the crankshaft for your harmonic balancer, okay? So another thing, I don't have my key in place on the bottom side of the harmonic balancer. Okay, you can see the groove is empty there. Okay, I have some key stock that I'm going to be tapping in there. But what I want you to keep in mind is when you have this in place, there is no keyway on the other side here of this sleeve. So you cannot run too much of a key stock. You know, it needs to basically be that length. Okay, so like I have this big old bar of key stock, and I'm gonna have to measure it and cut it just right, okay, so that I can keep my harmonic balancer in place and it doesn't turn out of phase. But if I put too long of a key stock in here, then what's gonna end up happening is that this won't fit. So that's kind of an issue that I'm gonna have to get worked out. And it looks like I'm gonna have to put that also on after the fact. So this is gonna have to go on first after my front timing cover's on, and then I'm gonna have to tap in this key stock. At least that's what I'm thinking at this point in time, because I don't know how I would slide this sleeve over if I had something in place there. So anyway, just something to keep in mind. There's always these differences on these engines, and this is just one of those differences that I'm seeing, you know. Anyway, so I'm not worried about it. I think it's all gonna work great. But that is that's the oil slinger, and now I can put on the front cover and get that sealed up, and that allows me then to install my oil pan. So that's another good thing. So coming right along on this big block Ford FE390. Okay, we got the Ford FE390 front cover here. This is the inside of the front cover. I've already removed the front main seal. This is the seal that is in the front of the engine. It's the opposite to the rear main seal. And I've already removed the old one that was in this, this factory front cover. Now to get these out, to get the old one out, so let's just say this one's in, and it was in place, all you do is just take like you can take a screwdriver or like a chisel and just tap it until you bend it in several locations, and then this will be able to, then you can flip it over and just pop it out from the other side by banging on it on the other side on that flange there. So and of course you don't care about the old one, right? So you can beat it up, but just don't damage your aluminum front cover, right? Because you want it to be able to seal up properly with your new seal. So anyway, damage the old seal, not the front cover. And then on your new front seal here, I usually put just a little bit of like WD-40 or a little bit of light oil on the outside. And then I take like a block of wood and I start tapping it in, okay? Make sure that, and if you look in here, there's a little spring, okay? That spring faces the inside of the engine. So just make sure that when you install this, that you have this, or the spring, facing the inside of the engine, just like this, okay? And you just tap it down flat so that this entire surface here slides in, and then the outside here bottoms out in here, okay? Anyway, pretty straightforward. So there you go. I'm gonna tap this in and get it into place, and then I got my front seal ready to go. Interesting, on this, on these Ford 390s and all the FE motors, small block Fords aren't like this, but you have this hub that actually slides onto the crankshaft, and this is where that front main seal actually rides. It's just different. So this is where the front main seal will actually be riding on, and it's a sleeve that slides over before you put your harmonic balancer on. So kind of interesting, these Ford FE motors. So anyway, that's it. All right, I've got the engine upside down again, and you can see that I have mounted the oil filter adapter onto the side of the block. There is a directional gasket that you put between the block and this aluminum adapter. Make sure you put the gasket on correctly. It's pretty self-explanatory. The one I used actually even said rear, so you knew that the rear part of the gasket went back here towards the back of the engine. Just make sure all your oil holes line up. I mean, again, really basic. And then I have the front cover on. You can see that the front cover's on. You can see the hardware that I have holding on the front cover. I did notice this front cover is slightly different than the front cover that I have on the engine that's in the truck now, but it's only here that it's different. So I'm hoping that that doesn't cause me any grief later on, or I find out why. You can see where this is where the fuel pump connects, and then this is that sleeve. Now, the sleeve is kind of ugly, I will admit. I guess I could have painted it. I don't think it will be seen, but the sleeve, I did put a little bit of light oil on the part of the sleeve that the front main seal rides on, okay? So there's a little bit of lubrication there. And I also cleaned that part so it's really smooth for that seal to ride. It's not gonna chew up the seal. This part is kind of rough and gross, and it would chew that seal right up, but the part that it rides on is smooth and oiled. And then you can see I have that piece of key stock there that I've put into place, and it's really firm in there. I tapped it in. It was easy to tap in, but it's not going anywhere, okay? And I think that's enough to keep the harmonic balancer in place. It certainly is high enough to get into the groove of the harmonic balancer, so we should be good there. And there's just a slight bit of play here, and I think honestly this might even move back a hair because the harmonic balancer gets pressed on. So we'll see, but I think this is gonna be fine. If I come in to where you can see inside the crankcase, again, you can see that the oil slinger is put on correctly. It is not touching the timing chain. Okay, so that's on correctly. And you know, I just used the gasket that was included in the engine build kit for the front cover, and I used a little bit of black art to seal it up. And honestly, once those bolts, or I should say, once the sealer is dry, the bolts really aren't doing much at that point, because it's gonna provide a seal. Okay, so this is all upside down and kind of goofy looking, but I'm gonna be really pretty much ready to install that oil pan. I did shave off the little bit of the trim the gasket right here on both sides where the aluminum front cover meets the iron block. I shaved the gasket with a razor blade, and I'll definitely use some RTV here. That's going to be a place where you could have a possible leak, because there's a potential transition there. So you're going to use some RTV there for sure when you're putting on that oil pan gasket. So anyway, that is the upside down motor with the front cover and oil filter adapter installed. As we plan to get this oil pan in place, you know, I'm just kind of going back and thinking through everything and double checking that things are tight and well thought through, okay? And that's what I've been doing. I do want to just make sure that everyone understands that anytime you have a transition, you're going to want to put RTV down even before you lay down your oil pan gasket, okay? So a transition would be from the block to the front cover. You got this transition here, and there's this gasket there, and yeah, it's really flat, and I've shaved down the gasket and all that, but you could imagine oil pushing through and leaking out the front of your engine on either side of the block. Or, even though it's less of a transition, you also have a transition between the block and the rear main cap that houses the rear main seal. Now I also have a little tiny bit of a depression where I filled the sides of the rear main cap with black RTV. And I filled this up, I can't remember if I talked about it on video, but there's a gasket that they give you. I just fill these up with RTV, but you have to do it really carefully and make sure that you get this black RTV all the way down. So what I do is I squeeze it down really hard. I get the nipple of the tube, a nipple adapter. I get that deep in there, and then I just squeeze real hard. And then I take the actual gasket they gave and I kind of push it down and I pack it in and then I keep, basically repeating that process until I get, I can't get any more in there, okay? But when it does shrink, okay? And so it's actually shrunk, and I have a little depression there. So on each side. And so what I'm gonna do is I'm gonna use RTV to fill these two transitions as I prepare to put on the oil pan gasket, okay? Now, on almost every engine that I build, okay, I use oil pan studs. And as you can notice, I don't have any studs in the block right now. The owner of this engine, he had some parts that he had already purchased and said, hey, go ahead and use these, save on cost. And so he has a set of just regular oil pan bolts, okay? There's nothing wrong with these at all. I like oil pan studs. I think the clamping force just feels better to me. And then of course, if you ever had to drop your pan while the engine was in the vehicle, I feel like it's easier to, get the oil pan all lined back up with the stud system. But again, it's really just preference. I don't think, either way is a bad deal. So anyway, we've got this oil pan gasket here, and you can see that it fits well. I'll line up all the holes. You'll also notice next to my oil filter adapter, I also have an opening. Okay, this is for the dipstick tube. So that's important. If you ran an aftermarket pan that had its own dipstick system, you'd want to fill this with RTV. But that's pretty uncommon. Maybe like in our road race pan, but who road races with a 390? I'm thinking small block Ford stuff. But anyway, that's where you're going to have the dipstick tube come through. So anyway, so this is the gasket that I'm going to use, and so I'm going to use some RTV on like a rubber cork gasket like this. I will use RTV on both sides just a little bit. I wished you didn't have to. Maybe you don't. On newer, like they have some really nice pan gaskets now, especially for like small block Fords that are made out of like a really nice sticky rubber, and you just know it's going to seal up. So I hardly use any RTV except for all my transitions. So anyway, we're going to be bolting on the pan now. And just one last thing is make sure you have a 1/2 inch clearance off the bottom of your pan, okay, for your oil pickup. And Yeah, you know, that's kind of looking ugly. I should have painted this. It's going to be totally covered up. You'll never see it. I did, like I said, I did clean the sleeve where it meets the front main seal, but this out here is really ugly. I should have painted it. Anyway, so yeah, oil pan. We're going to go ahead and put it on and continue making progress on this big block FE 390. All right, gaskets in place. Transitional areas have extra goop, and now I'm ready to install this brand new oil pan that has that front sump, and of course you can see front sump set up. So here we go. Let's go ahead and get this oil pan put on. Okay, we got an oil pan installed. So you guys can see all of these bolts are in place. And I probably went around and tightened them little by little about 6 times. I don't like to tighten them all down real tight one at a time. I just keep going around until I feel really good about them. I did use RTV all the way around the gasket on both sides, but a very light film. And I did snug these down hand tight with a ratchet. But they're snug, and I also use Loctite on each one. So I would, you know, if I had to guess, I'd say they're around 25 to 30 foot-pounds, but that's just a guess at this point because I did it by hand. But they are very snug without, you know, what I don't want to do is I don't want to squish out this gasket, okay? That gasket there, you can see a little bit of RTV oozing out just a little bit where it's probably a little heavier than other spots. That you do not want to squish out. So you don't need to gorilla tighten this, but you do want it to be very firm. And again, I use Loctite, hoping that these won't rattle loose. In my experience, they tend to loosen up a little bit. Some of the stud and nut kits that you can get have little grippers that kind of dig into the oil pan and help to keep it from them backing out. But anyway, these might need to be checked down the road, but hopefully with that RTV, they'll seal up and we won't have any issues with leaks. So there you go. We've got this front sump 390 oil pan installed. All right, so with the oil pan bolted on, we can turn the engine right side up and we can start talking about installing our hydraulic flat tappet lifters. Now the Ford FE engine, you know, it doesn't have any sort of lifter retainer to hold the lifters in place. So you don't really want to install the hydraulic lifters too early, because then you're not able to turn your engine upside down, because if you did, the lifters would just simply slide out and fall onto the floor. You can see I do allow my lifters to soak in oil. I let them soak for a couple of days. It doesn't really matter. This isn't even necessary, but I do it just to get the air out of the lifter and allow oil to flow into the lifter, and it kind of speeds up the pre-oiling process that I do before I start an engine. So again, not necessary, but you know, you can do it, and it's not a bad idea. Also, obviously, you know, then your lifters are all lubricated to slide into their lifter bores, and you get a little more oil on your camshaft and all that. So anyway, but keep in mind, this is a this Ford FE engine is a non-adjustable valve train, and so because we are using the factory rockers, and so we're not, you know, it's very basic. And so you're able to use an aftermarket camshaft like we are. You know, it's not a big cam or anything, but we're able to use an aftermarket camshaft, and we can do that with a non-adjustable valve train because we're running a hydraulic lifter. So, you know, it's the plunger, the spring-loaded plunger in the lifter is able to absorb, you know, variance from a slightly larger camshaft and keep the proper amount of, you know, pressure on the rocker arm as the engine is running. So anyway, again, this is a non-adjustable valve train, and so being that it's a non-adjustable valve train, it's very easy to install. You just bolt it down. And so we're going to be doing that next. But I just wanted to let you know that this is definitely the time you want to install lifters, because now you're not going to be flipping the engine upside down anymore, really. And once you do have the push rods and the rocker shafts and rockers in place, permanently, then you can, if you needed to, you can flip the engine upside down again, because, then the lifters are going to be held in place by the push rods having tension on them. But yeah, if you install the lifters too early, and then, you'd be like, oh shoot, how do I keep them in place, if I don't have the valve train bolted down, and you wouldn't be able to. So anyway, this is just one of those things that we kind of hold off until now, and now we can install these lifters. All right, as I prepare to install this intake, I did want to mention a couple of different things for preparation. As some of you may know, FE engines incorporated a valley pan that you would install underneath the intake manifold. That's the way they came from the factory. If you have the valley pan, or if you want to, or if you're trying to decide whether or not you need to use the valley pan, hopefully I can help you out with that as far as the information I provide. This is a heat riser port, and it comes basically exhaust comes back up as the engine's running, and it goes into your intake manifold. So just hot gas comes from your exhaust to your intake manifold, and it warms the intake manifold up quickly to help with allowing the engine and the carburetor to work correctly in colder weather. And that's the way that it's designed from the factory. So what that factory valley pan does is it protects, or actually it doesn't allow oil to splash up on the bottom side of the intake and like get burnt and get caked up, because the bottom side of the intake, because of these heat riser ports on both sides, okay, because of them, the intake gets really hot on the bottom side of it. And so you don't want that oil to get burnt and then caked, and then it causes it to like flake off and gets kind of nasty. So a lot of guys choose not to run the valley pan, and you know what, that's fine. You don't need to run the valley pan. But if you don't run the valley pan, just make sure that you block these off. So you can do that in a couple of different ways, but the right way to do it is to install a gasket like this Edelbrock 7224 intake gasket that, as you can see, blocks that off. And this material is designed to not, have a problem doing that job. So it's not going to, hopefully it doesn't burn through. But what you're doing is you're actually eliminating the ability for those hot gases to come into your intake. Now, this may be a bad thing to do if you're in a really cold environment where you need your, your engine doesn't like to stay running in the mornings, especially when it's really cold, but here in the West Coast, it's typically not a problem. So I am not running a valley pan on this 390. I am going to be using this 7224 Edelbrock gasket, which you can see the ports are the right size port on the gasket. And that's important. And then of course it's blocking off the heat riser ports on both sides, okay? You do want to use a little bit of RTV around the water ports, which are the ones on the very far ends on both sides, okay? And then the last thing I want to mention to you is that you're going to want to get a product called The Right Stuff. And this comes in different types of containers, but this is just a regular tube. And instead of running that really crappy cork gasket or even rubber gasket that sometimes Felpro and different companies give you for the front and the back of your intake, just use this. You want to make sure you have a fat enough bead, and you want to make sure that you put the bead starting here, up here, okay? And you run it all the way across and back up. Of course, this intake gasket will be in place, and just up past that notch, okay? So again, I'll have the intake gaskets in place on both sides, and then I'm going to run that bead in the front. I'm going to run that bead in the back, And then it needs to be fat enough, and you can tell because you set your intake on there, just mock it up and you can see the gap. So you know how fat this bead needs to be by just testing the fitment of the intake and making sure your bead is at least that fat. And then this particular product will squish down and it dries in 90 minutes. And it works really, really well. So that's what I recommend. And a lot of people would recommend to you just to use this instead of, because the cork gaskets and the rubber gaskets they give you, what happens is as you tighten your intake, they tend to squish out and you just they're just really prone to fail and leak. And this is not prone to fail and leak as long as your bead is fat enough, okay? So that's it. I'm gonna install both of these gaskets. I'm gonna put my RTV around the water jackets, and then I'm going to install the intake after I put down the right stuff, and I'm gonna bolt down the intake to the proper torque spec and the right sequence. So that's what's coming up next. Okay, this might end up being a more helpful video clip than my last clip, because now you can see how I have the right stuff beaded pretty thick across the front, touching both intake gaskets. I have black RTV that is not the right stuff. It's just regular slow drying black RTV around the water jacket ports, okay? That's actually Ultra Black by Permatex. Okay, same company, just different product, even though it looks the same. And then I have this big fat bead across the back here. Okay, again, probably fatter than I need it, but more is definitely better than less when you're sealing the front and back of your intakes, okay? I did use a little bit of RTV on the back side of this gasket here on both sides as well, just very lightly, just to get it to stick to the head, okay? And now I can set the intake on. Okay, we have the intake manifold installed. It is torqued down to spec. Each bolt is torqued down to between 33 and 35 foot-pounds per factory specifications. I also torqued it in a particular sequence, so let's talk about that. I'm gonna put my cheat sheet here because I'll forget when I'm doing this on video. Anyway, this is front of the engine is right here. And this is number 1, and this is number 2. Far corner, number 3. Go all the way across to the other far corner, number 4, okay? We're gonna go this way, far corner, number 5, as you might guess, all the way across to this far corner, number 6, and then we're gonna go to the second bolt in, okay? This is number 7, and we're gonna go diagonally to the second bolt in on this side, number 8, and then come across, second bolt in, number 9, and then finally we're going to go this way to my bolt here with the X on it. I'll explain that here in a second. That's number 10. All of my bolts torque down really nicely except that one. That one there, I could only get to about 28 foot-pounds, and then just wanted to keep spinning. So these are pretty inexpensive bolts because the torque rating on them isn't really that high. So I'm going to try another bolt there, but at this point I'm letting the intake dry because I think even at 28 foot-pounds it's going to be okay. And I'll replace it later. Now, as you can see, I have a really nice fat bead of the right stuff that's oozing out underneath the front of the intake manifold. Okay, that's what yours should look like as well. It's a little excessive here on the right side, but that's okay. Oozing out is fine. Also, just in case you're wondering, yes, this is a little bit dangerous. So it's not going anywhere, but when I go to remove it, I could drop it into the engine and that would be dangerous. So just, I am aware of that and I am very careful, but accidents do happen. As I come around to the back side of the intake, you can also see that I have a nice fat bead of the right stuff on the back side of the intake here. This one, I've smoothed it out with my finger, which is totally optional. It is not a part of the engine that you see, so I'm not worried about it, but I was just kind of making sure that bead was fat enough, and I'm actually very, very happy with it from corner to corner, okay? So the intake manifold is fully installed, and now I'm gonna go ahead and bolt the rocker assemblies down. You might be able to tell, if you're watching the video, that I have these push rods already installed, so they're making contact with the lifters on both sides of the engine, and now I'm ready to bolt those rocker assemblies that I've thoroughly cleaned down and into place. They're non-adjustable, so all I have to do is torque them down to spec. Okay, and man, we're almost done with this engine build. I'm excited to be done with it, and even more excited to install it into this 1972 Ford F250 pickup and hear it fire up and drive on down the road. So almost done. Let's finish this thing up. Here are the factory rocker arm assemblies off the 390. These have been cleaned up. I just soaked them in a solvent and then hit them with a wire brush for about 10 minutes and got them cleaned up. They were pretty nasty looking. I don't know how many miles they have on them or what their life has been like, but I did get them cleaned up pretty good, and then I just hit them with some Deep Creep, which is basically a fancy WD-40. It's better than WD-40, let me tell you. In fact, product placement here, Deep Creep. This stuff is awesome. They don't pay me any money to say that. That's how good it is. This stuff is fantastic for loosening up stuck bolts and stuff. But anyway, it's also a good lubricant. So went ahead and hit the assemblies with some Deep Creep to get them all lubricated after being in solvent for a while, and now they're pretty much ready to install. Okay, and getting ready to install these factory rocker arm assemblies. Don't leave out this tray, okay? This tray is designed to redirect oil that's coming off the rocker arms back to the valley. You can see they have these little spouts that direct oil down to the valley. Now, oil can get back to the valley through these openings here in the cylinder head, but my guess is that wasn't enough. Oil was collecting on the cylinder heads, and Ford decided they wanted to add this to help increase the flow back towards the oil pan or the valley to get to the oil pan. So again, don't leave this tray out, okay? Very important. This tray is a little ugly, but it's clean, and I can use it to, for the engine build. So anyway, just wanted to point that out. Okay, putting on these rocker shafts or rocker arm assemblies is quite simple. I'm just going to go ahead and set the rocker shafts in place on top of the cylinder head, and all of the bolts that are going through the rocker shafts are going to line up right where they're supposed to go, and you can just kind of start threading them in by hand. You'll want to make sure that you carefully line up all of the push rods to the underside of the rocker on the inside of the engine there, and then on the outside of the engine where the valve stems are at, you're going to just make sure that the rockers are kind of the proper location, and the rocker tips are resting on the top of the valve stems. So then just tighten the bolts down with your ratchet so they're snug, and then your final torque spec on this is 40 to 45 foot-pounds. So I usually will run them down to about 25 foot-pounds, and then all the way around the engine, and then do a final torque spec of 40 to 45 foot-pounds on those bolts. And then that's pretty much it. I'm ready for my valve cover gaskets and valve covers. So this is pretty much the end of the technical information for the 390 build here. After I'm done with this, I'm going to get the engine installed in the 72 Ford F250 pickup, and then we're going to pre-oil the engine. Pre-oiling the engine is really important. Definitely pre-oil any engine by using a special pre-oiling shaft that turns the oil pump with a drill, and usually it's reverse rotation, and then you're going to basically cycle oil through the engine prior to starting the engine up. Okay, that's really important. So that's just I want to mention that because everybody should be pre-oiling their engine before starting it up. And then this truck's gonna cruise on home. So I'm excited to be done with this project, and I'm excited for the owner to have a good running 390. So yeah, moving on.